The last thing that we sort of want to talk about, and we're super excited about this, and we really see a lot of scope to this in terms of the data ingestion API that I was talking about earlier, where the platform can take data from lots of different third-party sources. One of the main, top of mind use cases for folks are unified communications applications. So Microsoft Teams, Zoom, Blue Jeans, whatever have you, right? And Zoom is one particular one where we're working pretty closely with them from a partnership standpoint to actually get data directly from their API. And so, to the question that Keith asked earlier about, wait, how do you actually know that the user is suffering? Well, this is about as close as we're going to get in terms of the Zoom application directly telling you that things are going wrong with your Zoom video call or screen share or audio and whatever else. And really, it's targeted towards two use cases. One of them is the traditional work from office use case, where you're in the office and you're using Zoom and Zoom performs poorly or whatever it is, and you're trying to figure out what's going on, as well as the new sort of use case that we all have top of mind, which is work from home. And that's where we take Zoom API data along with the client app data that John just talked about and correlate those two to say, wait a minute, Zoom is bad because of wireless, or Zoom is bad, but actually wireless was fantastic, and something else is going on, jitter problems or whatever have you, right? And the idea is to stream these data sources in. And again, the platform is built such that whatever data is available, we're going to be able to analyze that as best we can. And the more data that can be put into the platform, the better the insight that you're going to get out of it. But the real top of mind use cases from an enterprise IT standpoint are things like, okay, first off, just what does normal look like? What is the baseline for Zoom experience? And if I make a change, right, and today sort of the changes that people are looking to make, especially from an enterprise IT standpoint, is maybe, getting better internet service, or maybe buying SD-WAN, right? Putting an SD-WAN edge in or that kind of a solution. But obviously, if you're going to do that for a lot of employees, you better be able to prove the ROI of, hey, wait a minute, Zoom performance was here, or UC performance in general was here. And after putting this SD-WAN system in, it got this much better. And objectively, I can prove that with data directly from Zoom themselves or the application themselves. So those are some very important use cases. Along the lines of that is, hey, who are my worst client devices? From a Zoom performance perspective or UC, what are service providers that are really bad? So we can tell employees to switch or, put pressure on those service providers or whatever have you, right? These are the kinds of use cases that we're looking to target with this. And so with that, let me actually show you guys as opposed to slides. So let me switch over. So hopefully you guys can see this. So this is the platform that everybody sort of knows. But what I really wanted to get to is when I type Zoom in. So John talked about the Zoom US application, and that's really us detecting Zoom off the span port or packet data, and us trying to automatically figure it out. But what we've added is this application up top, which is actually directly coming from Zoom. So when I click on this and I go to the application details page for Zoom, I get things like top talkers, and this applies again for people working from home using Zoom, or people, on campus or in a branch using Zoom as well. So you get top talkers, you get indications as to anybody having performance issues over the time frame that you're looking at. And most importantly, you get metrics directly from the Zoom API that sort of describe Zoom performance directly straight from the source of truth, right? The application server themselves. So you get input-output latency across screen share, audio, as well as video. You get input-output packet loss, bit rates, frame rates, resolutions. They even give you the CPU usage of Zoom versus your overall CPU usage as well, because obviously we all know that sometimes that can be the cause of a problem as well. So a lot of rich data directly coming from the application. Then this leads us to different types of use cases of helping figure out what's going on with the app. So one of those use cases is kind of a service desk-ish sort of use case where you just look for a user, you go to the client details page for that user. And basically, this is a user, for example, that's working from home. And so you see sort of their Zoom username and the camera and the headphones and whatever else. And as usual, we sort of pick up any problems that we've seen automatically, right? So this client experienced Zoom performance issues all the time that they used it, or that they had these issues. It was high video frame loss. That was the root cause. We also call out that, hey, other people using Zoom from, using AT&T, this person, 4 people were doing it from this particular company, and 1 out of 4 had issues. Other people using Zoom from Santa Clara, right? This is the percentage of people that were having issues, and so on, right? So we're able to sort of figure all that out. And then you can also, just as with any problem that we detect, you can click this View Evidence button and actually see the raw data that that sort of led us to this, right? So if I scroll down over here, that high video packet loss is over here, right? The packet loss you can see here from a Zoom standpoint is getting like 20, 30%. And one of the things that you can just really tie down to exact root cause, or like you can know for sure that this person is having a problem, because when you look at the output resolution, so obviously Zoom won't just drop your call if you have bad experience with Zoom. Zoom will adaptively try and reduce resolution to keep the call going, and then we'll put the resolution back up when it can. And so you can see that sort of go on, sort of as you can see. It was 640 by 480, then all of a sudden tried to reduce it to 480 by 360, tried to go back up, and so on and so forth, right? So you basically have all the evidence to know exactly what's happening here. And once we sort of tie this in with the client app, you'd be able to see sort of root cause as correlated. Now that correlation actually works if you have somebody that's out on campus.
Because you mentioned the agent again, seemed like a good time to ask.
Yeah, for sure.
Brady from Boise would like to know the licensing paradigm between the agent and Nyansa, and how is the platform licensed when it comes to the bits and pieces?
Yep. So the app right now, if you're a Voyance customer, you can have access to the app. Basically, and in fact, I mean, even if you're not a Voyance customer, for the self troubleshooting aspect of it, you'll be able to download it off the App Store as well. So that's the scenario right now. This actually goes back to like a suggestion that Keith had a while ago for us around the client agent, but maybe we'll make it happen for this app.
So, all right, thank you.
Yeah, no problem. Okay. So the example that I wanted to show here, this is a user that's actually on campus using Zoom. And so you see a lot more rich data in this sort of attributes card or whatever, like the access point that they're connected to and so on. But really interestingly, when I click over here to Zoom, bad Zoom experience, so you can see something similar. 100% of the time, this person had bad Zoom, it was high video frame loss, and 50% of the time it was high video frame jitter. But actually you see other root causes. So 100% of the time this person had bad Zoom, they were also located in a bad coverage area. Additionally, you also see 50% of the time they were on 2.4 gigahertz, and we saw them have high AP to client retransmission. And the other 50%, they were on, 5 gigahertz, having this kind of problem as well. So this is an example where we've taken a data source from the wireless controller, we've taken a data source from Zoom, and we've actually correlated the two pieces together to give you an exact root cause in this particular case of like, wait a minute, this is happening, but it's actually not, it's not a service provider, it's not the internet, it's not whatever else. It is actually this particular issue. And once you have more of these data sources, you get additional attributes over here as well. So how many people that were connected on the same AP at the same time were having the same problem? How many people in the same building or whatever else, right? And so you basically get a lot of interesting correlations in this way from the platform. So that's kind of one use case, which is, all right, from the perspective of a single user, how can I get to root cause? Then you get into sort of higher level use cases around, well, wait a minute, from an incident standpoint, right? So let me click over here on the Zoom incident issue. We automatically learn the baseline, and we're looking for deviations in the baseline to sort of bump up the priority of the incident at hand. In this particular case, this is not, this is a P5 incident. So we didn't see enough of a deviation from the automatically learned baseline to actually justify making this a high priority alert. But if this deviated a lot more, if this was up here, whatever it is, then that would have been a P2 or a P1, and the customer would have gotten an alert for it as well. Right, so that's one aspect of it. The next aspect of it is this network history. Whoa, my laptop went gamma on me. So this baseline over here is sort of a baseline. This is the way that you would basically have objective data to prove, all right, I made a change here. I expect to see performance get worse or better or whatever, and have evidence for it. And this is a baseline that just with any of our baselines, you can add a filter here, and you can sort of look at different carriers, cities, whatever filters you want to apply here, and basically say that, all right, I made these changes. You know, maybe I made a firewall change, or maybe I put SD-WAN in, or maybe I, bought more bandwidth for my service provider, whatever have you. Or maybe I want to compare different service providers. All of those use cases are possible in this interface over here. So this is the next use case of, hey, give me objective data as to what my Zoom experience is like, and when I make a change or an investment, what's the ROI of said investment? So that's the other side. And then the last one, this is the screen that's a bit of an eye chart, but it serves some really interesting use cases, especially given sort of the times we find ourselves in right now. I'm going to switch this over to client hours. And basically what this is showing is the worst, users or APs or service providers, whatever have you, over time, right? So over here on the client list, this is like a super relevant sort of list to say, wait a minute, in our enterprise, these are the users that are having the worst Zoom experience over and over and over again. This user over here, this device, has had 19 hours of bad Zoom experience in the last 2 weeks. This one's 17 hours, and so on. And basically, it allows enterprise IT to proactively prioritize these users to, get better service or whatever, or enterprise IT at least to help with productivity here, depending on what the root cause of the problem is. If it's wireless, then one solution. But if it's something with the WAN or internet or whatever, it's a different solution. So that's what enables that. Similarly, you can get views as, hey, who are the worst carriers or whatever it is. This is not necessarily the worst carriers because it's just the total number of hours. But if I switch this back to percentage, then you'd be able to see the worst carriers as sort of rank ordered or whatever it is. But you might want to filter that further and be something like, hey, give me the worst carriers in, I don't know, Santa Clara or in Boston or whatever have you. So those are some of the really interesting use cases that we're super excited about as well. In terms of, getting more to that goal, Keith, you mentioned this earlier, but it's one thing to say, hey, your application experience is bad because we see bad wireless or high DNS latency or high web performance latency and things like that. But that doesn't necessarily truly say whether a user is happy or unhappy. As we get data that's closer and closer to the client device itself and closer to the application itself and reported by the applications, that's when we can almost surely say, especially when I showed you guys that output resolution going up and down, we can, with no doubt in our mind, can we say that that user was suffering because his resolution was, his or her resolution was getting bad. So that was, what do you call it? That's the demo for Zoom. And that pretty much brings us to the end in terms of the stuff that we wanted to show you guys. So we figured we'd sort of try and leave some time here as well for questions and things like that.
I do have a question.
Yeah,
so,
fire away.
Maybe I missed it as you were saying that in the Zoom.
Yeah.
Where are you collecting that? Is that coming from your PIN app or your regular Nyansa client agent, or from where is that data that you're showing coming from?
Yeah, so whoops, this is the picture over here, right? So this data over here from Zoom is coming from Zoom's cloud API. So Zoom is obviously a cloud service or whatever it is. And from our cloud, we pull their cloud, or we talk to their cloud and say, hey, give us, for this particular customer, give us all of the client devices and their QoS for meetings that they're having on Zoom. And that's the data that we're getting.
So how do you get that client list? Is that everyone who has your client app on their machine, your agent? Or just
no. Oh, okay, yeah. Good point. So basically, these are two completely separate data sources. You don't need the client app. Actually, what I just showed you was a customer that doesn't have any client apps whatsoever. But basically what they do is they authorize the Voyance cloud to collect very specific API data from their Zoom instance, right? So let's say at VMware or whatever, VMware IT would authorize the Voyance app to collect QoS data from Zoom and nothing more than QoS data from Zoom. And basically we would ask the Zoom API or the Zoom cloud, give us for every single client device in VMware, give us the list of client devices and all of their QoS data for their Zoom calls. And that's the data that we put into the system.
And from that data, we'll create those client devices in Voyance based off of that data.
Exactly.
So we never have to see you anywhere else. If we see you in that API, we'll create a client for you and then start tracking and baselining your performance.
Exactly. It's the correlations where you start to get the other data sources involved. So the example that I showed you where I showed you an example where it's bad Zoom, but we saw them having bad, coverage or Wi-Fi coverage at the same time. We were basically it was this use case, work from office or campus in this particular case. We're from campus where the Zoom API data was telling us about the bad Zoom experience. And the wireless LAN metrics collected, I think these guys might be Aruba, I forget, was from the wireless LAN controller. And we're able to put the two pieces together to say that, this is the client that this is corresponding to. And we're able to say at the same time, these two things correlated with each other. And therefore, that's what was going on. Yeah.
Is the architecture still a appliance on premise? And what does it scale to if so?
Basically, there are two cases. One case is you have VeloCloud SD-WAN. In that case, you don't need to put any additional appliance anywhere to collect data because the VeloCloud edge itself is already there. It is your router, and it's already seeing all of the packet data, and it's able to collect that packet data and look at it. And sort of that becomes this data source over here, this packet data source, right? If you don't have VeloCloud SD-WAN, then the same architecture as before is what we have today. And that's a crawler to collect for packet data. It needs to sit within your branch or campus to actually look at the span port and like dissect traffic and sort of look at what's going on from that standpoint. But of course, the other data sources like, talking to the wireless LAN controller or talking to a switch or a radius server, or even the Zoom API or anything like that, obviously the data collection can sit in the data center, or it can just be directly done from our cloud as well, right? So that's what the architecture still looks like.
So from that perspective, then the other piece, and maybe Lee, this is another question you were asking, which is, so from an architecture perspective beyond that, so once the data is collected either through that edge or through the crawler, it's then sent to the analytics engine. And the analytics engine today is just as it has been, either in the cloud, which is where a majority of our clients sit, or in your data center in a private cloud appliance. And back to your question, which is, how does that scale? We have not yet reached a limit. We have not found a customer that we haven't been able to scale to. And today that's, nearly 1 million users, in a single site.
You guys, the Voyance product has always had some pretty cool, juicy stuff because of the visibility it had in watching all the traffic. Is it fair to assume, because I know we had short time today, is it fair to assume that all of that, goodness and visibility we had, not just on the wireless side, but also on the wired side, especially for network services, that's all still in there?
Absolutely. The platform is exactly the same as it always was, and it will be continuing into the future. It's just adding more stuff. And then, the VMware VeloCloud integration side is basically just about having an even better value prop from a self-healing and taking action perspective with the VeloCloud SD-WAN solution. And getting more data, obviously, from that system as well. But everything else that was good. Yeah.
And that's awesome. Some of the Twitter questions have been really around the app or the agent, whatever we're calling it there. So I don't what platforms are going to be supported? How does it work with the dashboard? How long will the data be there? What can you set with it?
Yep. So all 4 platforms are going to be supported. Or all 4 major ones: Mac, Windows, iOS, and Android. With iOS and Android, obviously there's a whole foreground versus background kind of thing where the app only collects data when it's in the foreground. And so it's sort of a little bit of a different use case versus on a laptop or a desktop with Mac OS X or Windows, you can have data being sent in the background. So you can get a far sort of longer view about what's going on in your environment. In terms of the amount of time we keep the data, it's just like with any other piece of data within the platform. It's 2 weeks for super granular raw data, like minute by minute metrics. And then for baselines, like the one I showed earlier about Zoom or whatever, that's kept for years so that companies can do sort of a year over year comparison of how performance has trended over time, as well as usage and adoption have trended as well.
Here's another Twitter question. I'm not going to try and butcher his name, but his first name is Oliver. He said, how would you extend client app type visibility to IoT devices not running these operating systems? Is it possible?
It's possible, but dangerous. I don't know if I want to put the client app on like an infusion pump or anything like that. So the more likely approach that we would go in that direction is similar to our partnership with like GE, for example, like an IoT device manufacturer. We would look to be getting data from their data source itself, right? So we would want to talk to the GE management system and get data about all those IoT devices from that perspective, because that actually lets you do two things. It gives you sort of closer to ground truth, just like we've talked about with Zoom, right? Because that's coming directly from the source itself. And secondly, we don't have to get into FDA approvals and whatever else of putting things on, supercritical devices. Obviously, there's a spectrum there, like maybe for certain types of IoT devices running like a vanilla version of Android or something like that, maybe you can put the Android version of the client app and get similar visibility. But as you get to the more and more critical devices, it's probably better to get data into the platform via our ingestion API.
And so I was going to add a little bit sort of on that end of that, which is the ingestion API. Today, the ingestion API is something that sort of a casual announcement, maybe a couple of months ago or earlier this year. But the ingestion API is actually running a significant amount of data through it, right? So we're collecting Mist API data through the ingestion API. Now the Zoom data, the client agent actually goes through that ingestion API as well. So, we've had people approach us and say, hey, I've got a client, or I've got an app, or I have a tool. We actually have a manufacturing partner that sends tool data to us about, performance from that device. There's no reason why we couldn't extend, if somebody is interested in doing so, sending that kind of data to that ingestion API. So it becomes pretty flexible. As we look at it, it's something we didn't want to go out and start writing a million different specific problems. And on it, I don't know if you want to, you talk Zoom, exploring Office 365 and Team. Again, we know that this particular problem statement, right now is focused on Zoom. They've got some great client data out there from a QoS perspective. But as others have it, Team and O365, would allow us to get that data. We don't want to rewrite this, right? We want to be able to look at the exact same type of data and allow comparisons. So it's pretty cool, and definitely we're seeing more and more of the market turn that way.
Yeah. And one thing, just last thing to add to that, is we even have customers that have some proprietary whatever application running in their system. And we're talking to them about how they can send that data to us as well, right? So we're trying to build this ingestion API layer to be very, very general, where people can start sending us any kind of data, but hopefully it falls under some kind of category, and we can figure out how to sort of say whether it's good or bad from an experience standpoint, and have all the analytics that we have related to it. So that's sort of really the direction that we're going in. Splunk does a great job of this from just log data and things like that. And that's probably like a good model for us to follow.